Good day, everyone! I am RINA MENDEZ. I am a senior high grade 11 STEM student from Iligan City National High School. For this video, we are going to discuss about the fundamental trigonometric identities and proving using the trigonometric identities. And before I introduce to you the fundamental trigonometric identities, please remember that the identity numbers that I use here is not universal or general. I only use these identity numbers so we can easily remember them. So these identity numbers will only be exclusive in this video, and I will only mention a few trigonometric identities that will be useful in proving later on. Reciprocal identities. Identity number 1. Cotangent theta is equal to 1 over tangent theta. Identity number 2. Secant theta is equal to 1 over cosine theta. Identity number 3. Cosecant theta is equal to 1 over sine theta. Quotient identities. Identity number 4. Cotangent theta is equal to cosine theta over sine theta. Identity number 5. Tangent theta is equal to sine theta over cosine theta. Double angle identities for sine and cosine. Identity number 6. Sine 2a is equal to 2 sine a cosine a. Identity number 7. Cosine 2a is equal to 2 cosine squared a sine squared a. Half angle identities for sine and cosine. Identity number 8. Cosine squared times a over 2 is equal to 1 plus cosine a over 2. Identity number 9. Sine squared times a over 2 is equal to 1 minus cosine a over 2. The identities that I mentioned earlier are important in proving or establishing other identities. For our example, suppose we want to prove cosine squared times theta over 2 is equal to tangent theta plus sine theta over 2 tangent theta. Before we start proving, we have to choose which side of the equation is complicated. So, if the left side is more complicated, then we have to choose case number 1, which is you have to manipulate the left side of the equation. Then, if you find it complicated on the right side, then you have to choose case number 2, which is you have to manipulate the right side of the equation. And take note, we have to provide reasons or explanations every time we manipulate our equation. So, in proving, we use fundamental trigonometric identities and valid algebraic manipulations like fundamental operations, factoring, cancelling, and multiplying. For the first example, we will use case number 2, which is we have to manipulate the right side of the equation, and that is tangent theta plus sine theta over 2 tangent theta. For the first step, we can use the trigonometric identity, which is identity number 5, or the quotient identity for tangent, and that is tangent theta is equal to sine theta over cosine theta. We arrive at this equation by using identity number 5. Our next step is to add the fraction in the numerator. So, sine theta over cosine theta plus sine theta is equal to sine theta plus sine theta cosine theta over cosine theta. And for the denominator, we have to multiply 2 with sine theta over cosine theta. So we have to divide our fraction. After dividing your fraction, you will arrive at this equation. Now, we have to reduce our equation by cancelling cosine theta. By multiplicative cancellation and multiplying both fractions, we arrive at this equation. Since sine theta is common in the numerator, we have to factor out sine theta from the equation. By factoring out sine theta from the equation, we have arrived at this equation. Then again, we have to reduce our equation by canceling sine theta. Now, we arrive at this equation by multiplicative cancellation. The equation looks familiar, right? It looks like we are almost there. So if you remember, we got this equation from the identity number 8, or the half angle identity for cosine, and that is cosine squared times a over 2 is equal to 1 plus cosine a over 2. Now, we arrive at this equation by identity number 8. So now, we have proven that cosine squared times theta over 2 is equal to tangent theta plus sine theta over 2 tangent theta is true. After proving the equation, remember to always put QED, and it is denoted by a small light tombstone mark or a tiny black square. It is an abbreviation for the Latin word
quod erat demonstrandum,
which means it has been proved. It is usually placed at the end of a mathematical proof to indicate that the proof is complete. For the second example, still the same equation, but we have to use case number 1, which is we have to manipulate the left side. That is cosine squared times theta over 2. For the first step, since cosine squared times theta over 2 is from the identity number 8, or the half angle identity for cosine, that is cosine squared times a over 2 is equal to 1 plus cosine a over 2. Then, we can use it to prove cosine squared times theta over 2 is equal to tangent theta plus sine theta over 2 tangent theta is true. Next step is to multiply the numerator and the denominator with tangent theta. We can't use other identities because, for example, if we use identity number 3, which is cosecant theta is equal to 1 over sine theta, it will be harder for us to prove the equation. Remember that we have to arrive at the equation tangent theta plus sine theta over 2 tangent theta. So we have to look for identities that will be closer to the equation that we want to arrive. By multiplying both fractions, we arrive at this equation. Now, it looks like we are almost there. So we can use identity number 5, which is tangent theta is equal to sine theta over cosine theta. But tangent on the numerator, that is on the right added, is the only tangent that we have to change. Now, we have to reduce our equation by cancelling cosine. Now, we arrive at this equation by multiplicative cancellation. And again, don't forget your QED. Now, we have proven that cosine squared times theta over 2 is equal to tangent theta plus sine theta over 2 tangent theta is true using case number 1. So, there is no unique technique in proving all identities, but familiarity with the different techniques may help. So, that's it, guys. Thank you for listening. I hope you learned a lot from this video. So, again, thank you and God bless.